The session today will be learning to understand types of functions and implied domains. So a function is set to be one-to-one if different x values to different y values. So here we can see that the x value here goes to 4, 2 goes to 2, 3 goes to 4, and 4 goes to 6. But this is not one-to-one. As we can see, we've got 1 and 3 are mapped to the same y value. Here we can see that everything is a function and it's also one-to-one. So we talked about before a vertical test. The vertical test was drawing a vertical line, and if it only crossed the function once, it was a function. So all of these we've got are functions. But with a vertical test, we can see that two x values share the same one. So which means it's not one-to-one. Same with a parabola. We can see that it's not one-to-one because one y value will share two x values. So which of the following functions are one-to-one? So we know that linear will always be one-to-one. We know a quadratic or a cubic will never be one-to-one because if we draw a vertical line, we can see it's crossing over 2 points, which means one y value is going to be sharing two x values. If we've got y equals 1 over x squared, the same thing is occurring with the vertical test. We've got 2 points, two x values sharing one y value, so it's not one-to-one. And finally, with y equals x to the power of 3, it will be one-to-one because one y value is going to be not shared with more than one x value. Implied maximal domain. Implied domain of a function is the set of all real numbers for which the rule of the function has a meaning. So that means if I don't give you a domain, or we're not looking at only a certain part of it, then it's what is implied by the graph. So with y equals 5 take away x squared, we know it is going to be a maximum parabola that has a vertical intercept and turning point 5. We can see here that the implied domain will be all real numbers, and we can see that the range is going to be from 5 all the way down to negative infinity. Likewise, with y equals square root x plus 2, we know it's going to be starting at -2 and going all the way down. So the domain will be from -2 all the way through to infinity. And my y value will be from 0 all the way through. So this means all my real numbers are positive and 0. Finding the implied domain and corresponding range for each of these functions. So this is typical squared function, so y equals 1 over x minus 2 in brackets squared plus 1. If we are looking at the domain, well, straight away we know that we have a asymptote here too. So it's going to be all real values except for 2. Likewise, my range will be anywhere from this point here, which is 1, because I've got an asymptote of 1, all the way So then I write it here as the domain is equal to real numbers except for 2, and range is going to be in brackets 1 to infinity heart equal. By semester, we can see straight away that my radius is 3. So in terms of my domain, straight away here we can see that it's going to be between -4 and 2 and inclusive. My range is starting at 0 and going up to 3. Draw the graph of the function that is described by all real numbers and is graphed with real numbers of f of x is equal to x squared plus 3x plus 2. So if we are going to draw this graph, there's a few points we need to know. One is we need to know our x-intercept, our y-intercept. So straight away, I'll just do the working out. We've got a y-intercept at 2. We need to factorize this to be able to, again, work out the x-intercept. So straight away I can see I've got a times, let's say a is 1, so 1 times 2 is 2. They must time together equal 2, add up to 3. That will give me 1 and 2. So I could rewrite that as x plus 2, x plus 1. So straight away that tells me I've got x-intercepts and x equals -2 and x is equal to -1. So my turning point will be halfway between them. So straight away I can see here I've got my intercept of 2, I've got my so y-intercept of 2, my x-intercept of -2 and -1, and the turning point's halfway into my equation. Now the next part of the question is saying by restricting the domain of f, form two one-to-one functions that follow the same rule as f. So that just means we need to look at where the turning point is. I'm just going to draw a line here. If I cut it down the middle here with my domain, then that just means that I've got every y value has one x value. Meets the horizontal vertical line test. So I'm going to just circle my x point, which is -3/2. So I'm going to be writing it exactly the same as what I've got here, except instead of saying real numbers, my first equation will be negative affinity to -3/2. And my second one-to-one function will start at -3/2 and go to positive affinity. So we're going to do the same thing here. Is just draw the graph, which we've done. If following real numbers is described by all real numbers, f of x is equal to negative in brackets x minus 1 in brackets squared plus 5. So when we are rewriting this, we are going to be looking at our turning point. Now, our turning point is at the moment at 1 and 5. So it's that one value we're going to be using as our point to cut our graph in half. So it's going to be our domain will be 1 to positive affinity, and it'll be negative affinity to 1. So let's look at this next part. Sketch the graph of f of x is equal to x plus 4 when x is less than 0. We've got x squared when x is between 0 and equal to 0 and greater than and equal to and less than 2. And then 6 minus x when x is greater than 2. So when first thing we do is just graph x plus 4 and x squared, which is my parabola. only part of it is showing. And then x is greater than 2 will be from 6 or here all the way down. So the next part, when it says find f of -3, that's saying x is -3, which means I have to be using this part. X is less than 0. So I grab my equation, x plus 4, I then substitute -3 in, and look at what a plus 2 in terms of a. Well, at this point, I don't know what my a value is going to be, so I'm just going to have to substitute that into my equation. So in this case here, I've got a plus 2 plus 4, plus 2 squared, and I've got 6 take away a plus 2. Now, I just had to maneuver to get a by itself. So when I put a plus 2 over here, to take away 2 on the side to find out what a was. Even functions. So an even function have rotational symmetry with respect to the origin. So which means if I put in negative x, which is what I can see here, put in negative x, it's going to be giving me the same answer as f of x. So if I put leave, which is why it's sharing a y value. So let's have a look at this. If I put it into my equation, I just simplify, and I solve it, and I get identical. Odd functions. Odd functions have rotational symmetry with respect to their origin. So we can see here that an odd function is if I put f of negative x in, then it's just whatever my y would have been, it will be a negative on the other side. Let's double check if it works here. F of x is equal to x to the power of 3 minus 2. I put my negative in, x, negative 3, well, it would just be negative 3 and negative positive, so it will become plus x. So therefore, we can say it's the same. We put the negative x out there and then apply that to this.